Ever wondered how your TV remote just works? It's all about this invisible world of infrared. And in this explainer, we're going to harness that exact same power. Seriously, by the end of this, you'll have built your very own infrared transmitter using an Arduino, all set to send out your own wireless commands. Let's get right into it.
You know, we use infrared technology pretty much every single day, probably without even thinking about it. It's that invisible light that your remote uses to send signals across the room. We can't see it with our eyes, but it's an incredibly powerful tool for wireless communication, and we're about to put it to work for us. So, meet the star of our show, the KY-005 infrared transmitter module. This tiny little thing is basically a special kind of LED that emits light, but in the infrared spectrum. You can think of it as your own personal messenger, ready to deliver invisible messages whenever you tell it to.
Okay, so what exactly will you need to build your own invisible messenger? Let's take a quick look at the parts list. Don't worry, it's a pretty short one.
All right, here's our team. We've got the Arduino Uno, that's the brains of the operation, the KY-005 module, which will be our voice, a breadboard for super easy solder-free connections, and some jumper wires to hook it all up. And we can't forget our unsung hero, the 220-ohm resistor. This little guy is absolutely key to keeping our project safe, and we'll see why in just a minute. With all our parts laid out, it's time to get our hands dirty. Let's start building the circuit and see how all these pieces actually connect together. But wait, before we connect a single wire, we need to talk about safety. When you're working with components like LEDs, there is one golden rule you just can't afford to break. Always, always protect your components. And this slide shows you exactly why that rule is so important. See, the Arduino puts out 5 volts of power, but our little LED, it can only handle about 1.1 volts. If you connect it directly, poof, you'll fry it in an instant. That's where our resistor comes in. It acts kind of like a bouncer at a club door, only letting a safe amount of current get through. So how do you pick the right bouncer for the job? Well, it all depends on your power source. Since we're using a 5-volt Arduino board, our perfect match is a 220-ohm resistor. This is going to keep our LED happy and our whole project running nice and smooth. Okay, with our safety measures in place, it's time to look at the final blueprint. This right here is the complete circuit we're about to build. And as you can probably see, it's surprisingly simple. Let's just walk through the connections one by one. First, we'll connect the ground pin on the KY-005, that's the one with the minus sign, to a ground or GND pin on the Arduino. Easy enough. Next, we connect the signal pin, which is marked S, to one side of our resistor on the breadboard. And finally, connect the other side of that resistor to digital pin 3 on the Arduino. That's literally it. Oh, and the middle pin on the module, we can just ignore that for this project. All right, our hardware is all set up and ready to go. Now it's time to give it a brain. Let's dive into the code and actually bring our transmitter to life. Now, to save ourselves a ton of time and effort, we're going to use something called a library. Think of it like a pre-written set of instructions that handles all the complicated stuff for us. We're going to use the IR Remote library, which you can install right from the Arduino IDE. This little gem is going to do all the heavy lifting when it comes to sending our infrared signals. Let's take a quick look at the setup function in the code. This part runs just one time, right when you power on the Arduino. The key line here is irsender.begin. This one simple command tells the IR library, hey, get ready to send signals and do it from pin 3, which, of course, is exactly where we connected our transmitter. And now for the main event, the loop function. This bit of code runs over and over and over again, and it's what sends our infrared signal every second. The irsender.sendNEC command is where the magic happens. It uses something called the NEC protocol, which is just a standard language for remote controls, to package up our data and shoot it out into the world. And that delay, 1000 at the end, that just tells the Arduino to pause for 1 second before doing it all over again. So, our circuit is built, our code is written, it is time to put it all together. Let's upload the sketch to the Arduino and see if our invisible messenger is ready for its very first mission. This is the moment of truth. But, hang on a second. If our signal is completely invisible, how in the world do we know if it's actually working? How can you possibly test something that you can't even see? Well, here's a fantastic little secret. Your phone's camera can see things that your eyes can't. Just open up your camera app, point it right at the LED on your transmitter, and you should see a faint purple light blinking on your screen. That's it.
That's your invisible signal revealed.
So what have we actually accomplished today? Well, we've learned how to send invisible messages with infrared light. We've mastered the critical art of protecting our components with a simple resistor. We've harnessed the power of a library to make coding a total breeze. And now you have the fundamental skills to build your own custom remote controls and start automating your world.
You've actually done it. You've built a fully functional infrared transmitter. You now have the power to send signals through the air. But, what's a message without someone there to receive it? The next logical step is to build a receiver so you can catch those signals and actually put them to use. And so that leaves us with this one big challenge. You now have the power to control the world around you, one invisible signal at a time. The only question is, what will you create? The possibilities are truly endless. Now go out there and build something amazing. What if I told you that you could control the world around you with a beam of invisible light? It sounds like something out of a sci-fi movie, right? Well, today you're going to learn exactly how to do it. We're about to unlock the power of the KY-005 infrared transmitter. It's a tiny little module that's going to let you add remote control powers to pretty much any Arduino project you can dream up. So here's our game plan. We'll start by talking about the magic of infrared itself. Then we'll get to know our transmitter. After that, we'll cover the one golden rule that'll save you from frying your components. And then the fun stuff. We'll build the circuit, write the code, and finally, I'm going to show you a cool trick for how to actually see the invisible. All right, first up, what exactly is this invisible force that we're about to start commanding? Let's take a quick look. Every single time you pick up your TV remote and change the channel, you're using infrared, or IR for short. It's just a type of light that's on a frequency just beyond what our human eyes can detect. But it's absolutely perfect for sending simple commands from one device to another wirelessly. It's super reliable, it's simple, and it is everywhere. And this little guy, the KY-005, is going to be our tool for harnessing that power. Think of it like a tiny, focused flashlight, but one that blinks in a special language that other electronics can understand. This module is the key to making your own custom remote controls from scratch. Now, to actually use this thing, we just need to understand its three key parts. And don't worry, I promise, it's way simpler than it looks. There are really only three connections you need to know about. That big, clear bulb on the top, that's the emitter. That's where the invisible light actually comes out. Then you've got the 3 pins. S stands for signal. That's how we're going to tell it what to do. And the pin with the little minus sign, well, that's our ground connection. See? Simple as that. Okay, now I need you to pay close attention to these two numbers on the left, 1.1 volts and 20 milliamps. These are basically the operating limits for our little IR LED. And that 1.1 volt number in particular, that's the key to this entire project. Keep that number in your head because it's about to become very important. And that brings us to what is honestly the single most important part of this whole explainer. Before you even think about connecting a single wire, you have to know the golden rule. So, an Arduino Uno pushes out 5 volts from its digital pins, but remember our little LED? It's only rated for 1.1 volts. If you connect them directly, you get this. A sad little puff of smoke. You've basically just sent way, way too much power through it and burned it out instantly. So the crucial takeaway here is that you need some kind of protection. And in the world of electronics, that protection comes from a resistor. It basically acts like a dam for the electricity, choking the flow down to a safe level so our little LED can do its job without, exploding. And the best part is, you don't even have to do any math. As this chart shows, for a 5-volt Arduino like ours, the perfect choice is a 220 ohm resistor. That is our golden ticket. All right, theory time is over. With our golden rule locked in, it's time to stop talking and start building. Let's get this thing wired up. Here's our super simple parts list. You'll need an Arduino Uno, our KY-005 module, that all-important 220 ohm resistor, a breadboard to make the connections nice and easy, and just a few jumper wires. That's it. And this right here is our blueprint. This is what the finished circuit is going to look like. See how that resistor is sitting right in the path of the signal pin? It's like a little bodyguard for our LED. Okay, let's build this thing step by step. It's really just 3 simple steps. First, connect the ground pin, the one with the minus sign, on the module to a ground pin, or GND, on the Arduino. Second, take the signal S pin and connect it to one leg of your resistor. And finally, connect the other leg of that resistor to digital pin number 3 on the Arduino.
And you're done.
The hardware is complete. How easy was that? Now it's time to actually give our circuit some instructions. Let's head over to the software side of things.
To make our lives a whole lot easier, we're going to use a fantastic pre-written library. So in your Arduino software, just go to the Library Manager, search for IR Remote by Ken Sheriff, and click Install. This thing is amazing. It handles all the complicated timing and protocols for sending IR signals for us.
Now for the code itself. The setup function runs just once, right when the Arduino starts up. The most important line here is this one, irsender.begin. This one command is what activates the entire IR library and tells it that we're going to use pin 3 to send out our signals. Next up is the loop function, and this part just runs continuously, over and over again. The real heart of our program is this single command right here, irsender.sendNEC. This is the line that takes a piece of data, packages it all up using a standard remote control protocol, and sends it pulsing out from our IR emitter once every second. Okay, the circuit is built, the code is uploaded, so you should be transmitting an invisible signal every second. But how can you be sure? I mean, you can't see it, right? Well, here is a fantastic little trick. While your eyes can't see infrared, your phone's camera probably can. So go ahead, open your camera app, and point it right at the emitter. And if everything is working, you should see this beautiful, ghostly purple light blinking back at you. That's it. That's your signal. So, you've done it. You have successfully built an infrared transmitter. But sending a signal is really only half the fun. The true power comes when you build a receiver, maybe something like the KY-022 module, to actually catch those signals and make other things happen. You now have a fundamental building block for custom remote controls, for simple wireless data links, or even for setting up automated triggers around your home. You've learned how to send commands invisibly through the air. So the only question left is, what are you going to create with this new power?